So good morning everyone, my name is Joy Misagaino and my topic is all about box whisker plot and the pie graph. So box whisker plot defined as a graphical method of displaying variation in a set of data. Box whisker plots are very effective and easy to read as they can summarize data from multiple sources and display the results in a single group. So, this is a very useful graph depicting the distribution of test scores through their quartiles. This first quartile or Q1 is the point in the test scale below which 25% of the scores lie. The second quartile is the median, which defines the upper 50% and the lower 50% of the scores. The third quartile is the point above which 25% of the score lies. For example, the data of the test scores of 100 college students produce this image using the box plot approach. Looking at the box plot graph, the shaded rectangle represents the middle 50% of the test data. The line that divides the rectangle is the median, and the rectangle is referred to interquartile range box. So the top side of the rectangle is the Q3 or third quartile, and the bottom side is Q1 or first quartile. As such, this type of graph will help readers easily see where the scores are concentrated or how the scores are distributed and divided into quartiles. So, what scores separates each quartile as well as the minimum and maximum values. So, the whisker are the lines that extended from either the top side or lower side of the box. This whisker represents the range from the bottom and the top of 25% data values excluding outliers. It is the number you see outside the whiskers. So outliers can send important message about the certain phenomenon. For example, if you want to exempt students from a final examination, the outliers at the top will indicate who can be exempted. At the same time, those on the other extreme might need more attention and assistance to perform in the class. Next is pie graph. So, pie chart displays data, information, and statistics that easy to read and like in a pie slice format with varying slice sizes telling you how much of one data element exists. The bigger the slice, the more of that particular data was gathered. One commonly used method to represent categorical data is the use of a circle graph, and we've learned in basic mathematics that there are 360 degrees in a full circle. The categories can be presented by the slices of the circle that appear like a pie. It is called pie graph. So the size of the pie is determined by the percentage of students who belong in each category. For example, in a class of 100 students, results were categorized according to different levels, which showed that 10 students or 10% scored above average, 40 students or 40% is the average, 30 or 30% below average, and 2 to 0 is 20% poor. These percentages will be indicative of the size of the slices in the full circle. So, the simple calculation shows that 10% of 360 is 36 degree, 40% of 360 is 144 degree, 30% of 360 is 108 degree, and 20% of 360 is 72. So, the total of percentage is equal to 360 degree. You can use an ordinary protractor or compass, and you need to label each portion of the pie with different shades to indicate the categories and label of the whole chart. So that's all my report. Thank you and